A friend of yours says the vertical distance between flight path DB and the parabolic path CA will never be less than 40 centimeters. Is your friend's statement correct? And show all working. So we're going to prove that the distance between these points here will never be, or will, so the vertical distance between will never be less than 40 centimeters. So that's what we are trying to disprove, I guess. And we have to show all the working. So we need to come up with a function that describes the distance between these 2 points. And we can see the distance is described by this straight line minus the y value of our parabolic graph. That will give us distance. And we need that for all x values here. So what we're going to do is we're going to take g of x and subtract f of x from it. This will give us the distance in terms of x, and this will be equal to minus a half x plus 5 minus in brackets minus x squared plus 2x plus q, which was 3. Then we can combine some things. We're going to come out with a positive x squared and a minus 2x minus a half. That's going to be minus 2x. Let's just put minus a half x here, and then plus 5 minus 3, like that. And then this can be simplified to x squared minus 5 over 2, which will be minus 2.5, and then plus 2. This is the formula that describes the distance, and we can see it's in the form of a quadratic equation and a smiling one at that. So it shows that the distance in decreases. So if this is, if the if the y-axis represents distance and this represents x values, we can see that as the x values, so it should be something like this. As the x values are decreasing, so approaching 0, we should, or approaching whatever the turning point here is, we see that our function, the distance between the 2 points is decreasing and should actually be more of something like that. This will correspond to C, this will be the turning point, and this will be A. You can see it decreases, and then at some point it turns around, which is at that point, and then the distance starts increasing again. And that's what we see over here. The distance starts increasing again. And you just need to look at the y-axis as the value of dx, and you'll be able to see this. So what we're trying to prove, our friend says that the flight path will never be less than 40 centimeters. So we need to prove that the lowest distance here is going to be greater than 40 centimeters, or we need to find what the lowest value here will be. And to get that, we need to find basically the turning point of our function. And we can either do the first derivative method, or you can just say x will be equal to minus b over 2a, of which you get an x value of minus 5 over 4. Be careful when working with multiple fractions like this. Minus 4 over 2 actually, all over 2a, which is 1. Putting this on your calculator gives you 5 over 4, and at this value we want to find out what the distance is. So we take this 5 over 4 and we put it back into the question. So back into the distance formula, I mean. So we want to find out what our distance is when our x is 5 over 4. That will be equal to 5 over 4 squared minus 5 over 2 times 5 over 4 plus 2. And the minimum vertical distance in this case will be, if you put this on your calculator, you get 0.4375. and this is in meters. So this is 0.4375 meters. So this is the smallest distance, that is the distance over here. And that distance is described as the y value at this point here. That distance there. That's the smallest. All the other x values you can put in will give you a distance that is larger than this. So if you put in this one, for example, you get a larger distance. But yeah, so we have 0.4375. Put this into centimeters. This is 43.75 centimeters. So was he correct? Or was she correct? Who knows? The vertical distance between flight path BB and the parabolic path CA will never be less than 40 centimeters. Turns out they were correct, and the minimum distance is 43.75. Let's just write that down. Reason being 43.75 is greater than 40 centimeters.